Okay, so we need to take our designs into Netfabb to check their wall thickness and check that they are all ready to print. Um, One of the first things we probably want to do is make sure that our scale is going to be accurate. So if you haven't been doing this throughout the project, or for the last few iterations, making sure that your scale is at an accurate and kind of reasonable size, best to do this now. So make sure that you have that you're able to create an object that can let you see the scale, or that you are measuring the scale on the edges of your geometry by checking the edge length of the geometry. The easiest way of doing this is going into like a cube or something, or pulling a cube into your scene, um, and then editing that cube. So going into edit mode and selecting the cube and scaling it in here so that your scale multiplier here under your object properties tab remains at 111. So that way you'll get a realistic sense of the size and scale of this edge or any of these edges relative to basically everything else in the scene. So you can see here I've got the face orientation on so that I can check and see if there's any flipped faces or broken areas of my geometry. And I also have the edge length measurement turned on here so that I can see the edges here in this object or in this cube. And so this edge is about half a meter. And for these kind of coffee table sized things, that's going to be kind of roughly where I want it to be. So I know that when I pull this into Netfabb and look at it, I'm going to be able to see, it's going to be roughly like, half a meter or zero point 0.6, 60 centimeters, 600 millimeters across the top here. And then I can scale it accordingly. Okay, so let's export these objects individually. So we'll grab this one here. This one's broken, but that's going to show you kind of what happens in Netfabb and what you can and cannot fix in Netfabb. And then the other two are where you should be at, which is, nice clean geometry, clear flow of topology, and no kind of visible errors or in the surfaces at all. Here, you can clearly see these visible errors with self-intersecting faces, things that are just not lining up properly, going through each other, back to front surfaces and things like that, and very thin geometry as well. So when we perform a wall thickness on this, it's probably going to fail. Okay, so from here we can go File, select our output, go to File, Export STL. Let's create a new folder on the desktop, and we will call this yeah. Ooh. Yeah, cool. Okay, we've got 204 and we'll go into test STLs here. That's the folder I made for this. I've got tissue frame. Let's just call this 1. Gonna make sure we're including selection only here. And we're going to apply the modifiers here. So we can go now export STL. And then I'll show you kind of how the scale affects things by exporting these two slightly differently. So we'll take this one, export this STL file, call this tissue frame 2, but this time we're going to scale it up by 100. And then we're going to export STL. And then this one here, we're going to do the same, export STL, and we're going to scale this one up by 1000. And we're going to call it tissue frame 3. Okay, so now that we've got those exported, we can jump into Netfabb and import them. So we'll go add part, and we'll go to test STLs, and we'll choose tissue frame 1 and open this one. Cool. So now this one's good. It's showing us that we've got some issues, that the quality is bad, or that there's a problem with the quality. So you can also see here that as we pull this in, our size is 0.6 millimeters, so that's, under 1 millimeter. So this is clearly a problem with the scale. But anyway, let's add that part anyway, and we'll zoom in on it, and we'll see that it's way, way too small. So we'll go to scale this up. We'll select our tissue object here, or select our STL file here, go to scale, and scale factor, we'll go 10, and we'll make sure that it's fixed scaling, and we'll hit apply. Okay, cool. So now when we select this object here, we can show that its size is 6.9 millimeters. So again, too small. So we can scale it up by another factor of 10. You'll notice that these remain the same. So if we apply that now, then we have this, 69 millimeters and basically 70 centimeters across, or 70 millimeters across, 7 centimeters across. So this kind of fits within our 100 by 100 by 100 millimeter ballpark that we're aiming for the STL print size. Okay, so the next thing we might want to do is maybe jump out of our scale tool and maybe we want to do a part repair, or at least kind of analyze the part. You can kind of see here we've got this big exclamation mark saying there's issues with our part. So if I click on part repair here, we're going to see that if we zoom in here, we've got some unclosed edges, and so that's going to be a problem for us, or at least they're not unclosed, but they might be back to front. So let's see if we can repair this. The likelihood being we can't, but we'll give it a go anyway. So we'll select our part repair process here, jump into the repair script, and we can go extended repair, and then run repair script down here, and we'll see what happens if we click execute. Okay, cool. So it's actually made it worse. It's flipped these kind of broken areas inside out, and generally just made a mess of the mesh. And that's to be expected because it's just not a good mesh. So you can't really fix something like that where there's just glaring issues with the mesh. You need to have control over that in Blender itself. So it kind of means going back to the component, going back to the base mesh, and making sure that those actually work together to create a viable mesh for output. Yeah, that's pretty much the only way of repairing something like that is just going back and fixing it. If you have minor issues with the mesh, we can repair those using a repair script, but nothing where it's just not working, like you've got these massive areas that have just flipped inside out. That's just not going to work. Okay. But that is the repair script, and sometimes it will help you and sometimes it will make things worse. Okay, so let's have a look. Maybe now that this isn't really a viable mesh, let's maybe have a look at something that is. Okay, so let's right click and remove this part. Yes, and let's try adding frame 2. Okay, add this part. Quality looks good. That's generally a really good sign if you've got the green check when you bring it in. And we'll add that part. It's off here in the distance, so maybe we want to center this part. I think we can do that with the move tool. We can go to platform or to platform center, and that will allow us to just kind of quickly move that part right into the center of our platform. If we have a look at the size, then that was good. So we scaled it up. This is the one we scaled up by 100 times. And that's taken it to 50 millimeters by 50 millimeters by 45 millimeters, which is within the scale that we want for our SLS printing. Okay, let me just move this over here so it's right at the corner. And this one we can run a wall thickness analysis on to check that we are not going to have any issues with the print quality. So if we go and select our tissue frame 2, go to new analysis and click on wall thickness, we can do a wall thickness analysis, and we can use this wall thickness threshold to check that we are within the wall thickness allowance of SLS printing, which is generally supposed to be about 1 millimeter. So if we put 1 in there, 1.0, and hit enter, it's going to give us a 1 millimeter threshold. And now when we click OK, it's going to run a wall thickness analysis to make sure that everything is above that 1 millimeter threshold. Okay, so it's all green, which is great. That means everything's above our wall thickness threshold. So you want to probably screenshot this because you'll need to submit this. Maybe let's have a look at something that might fall under that wall thickness threshold. So if we jump back into Blender and just do a few edits on this, let's go to our tissue settings here, and let's just reduce the frame thickness until we have something that's really not going to work. Okay, and we will go File, Export, STL, and we'll export this one as 4, and we remember that our scaling was right if we were in real world scale in Blender. If we scale by 100, it'll get us to the kind of like 10, within the 10 centimeter boundary in Netfabb. Or at least for this file it will. You will have to figure this out for your own work. But generally, if you're working within a meter by a meter within Blender and in Blender units, then a scale of 100 will get you to the right scale for SLS printing, or at least for our usage of SLS printing. So we call that tissue frame 4. Going to export the STL. We'll close the part analysis here, and then we can either remove this part, or we can just add a new part. Select tissue frame 4 here, open that, and you'll see 50 by 50, that's perfect. One shell, that's perfect. If you have seen the last Netfabb video on repairing things with multiple shells, then it's important to just have a single shell. And we've got a few triangles there as well, and we'll check that our quality is right. Okay, cool. So we'll add a part, and cool. Over here, again, we can go to move, and we can move it to the center of the platform, and then we can find our platform again, and here we are. So this one here, if we check, you can see that these areas here are just substantially thinner than these ones. So this, I already know this isn't going to print, but it's worth seeing what happens when we run a wall thickness analysis on this as well. And again, we'll change that to 1 millimeter. So just type 1, press enter, hit OK. And then when we run our wall thickness analysis on it, it's going to show us, basically that nothing's in the green here. So we can see here that only maybe some of these areas, these really thick areas, will print reliably, and everything else is really under this 1 millimeter boundary, or this 1 millimeter threshold. So if you run a wall thickness analysis and there's lots of red on it, it's just probably not going to print. Again, another thing you're just going to have to go back to Blender and change. In all of the settings for all of the different tessellation modes, you're going to have like thickness scales and frame thickness scales for like the frame fill mode. But for any of these other fill modes, you're going to have thickness scales and things like that you can use to like beef up the boundaries of your mesh. And you're going to have to do that carefully, and you're going to have to do that with the same simplicity of components and base meshes in mind, because otherwise, if your meshes are too kind of all over the place, it's just going to cause more problems. Cool. So hopefully that has shown you how to do the thickness analysis. You'll see that that's actually kind of submitting your thickness analysis is going to be a requirement just to make sure that when we send your files away, um, they are all, oh God, they are all um, ready to print and won't result in kind of lengthy back and forths between the manufacturer and yourself. So it's a part of kind of covering yourself, making sure that you're not going to waste your time, you're not going to waste your manufacturer's time. In creating, in creating more problems for yourself, by not observing your geometry and making sure it's ready to be submitted for manufacture.